Hey, welcome to this SAINTCON session. Today, I'm going to be covering serverless and dysfunctional cloud red teaming. So specifically, we're going to be talking about how red teamers can leverage various services within cloud providers to get more work done faster, better, smarter by leveraging serverless technologies. And I'll walk you through some of the options with those technologies in this section, as well as a few common use cases that I've come up with that I think are, a little bit outside the box. So, stay tuned. It's going to be awesome. All right, introduction. So, I'm Bryce. On Twitter, my name is TweakFox. I was part of the founding team of Stage 2 Security. Prior to that, I founded a red team at Adobe, and prior to that, I was a technical director at the NSA over an offensive unit, and then prior to that, I was over incident response and focus operations at Homeland, where we, hunted down APTs and got them off networks, right? So in my spare time, I also run the B-Side Salt Lake City conference with a great team executing that conference every year, as well as, big supporter, love what Troy's done with SAINTCON, and look forward to this event every year. Stage 2 Security, I am currently the Chief Strategy Officer there, and, it's grown quite large over the last few years. We're still kind of a boutique shop that focuses on cybersecurity services. And namely, we kind of have the two sides of those services. One side is adversary simulation. That's really where our pen testing and red teaming services come into play. We do a lot of pen testing and red teaming of cloud environments, AWS, Azure, GCP, O365, G Suite, that type of stuff. And, for both, small startups that maybe are looking to get acquired in the near future, as well as for large tech companies. In addition, we have an adversary prevention side of the house that does services that helps find hackers inside of networks. We have a lot of expertise on the Phantom and Splunk platform. We have, I believe, 6 Splunk trusters in the company, which are kind of like the MVPs on the Splunk platform, and some of the world's best on Splunk's SOAR implementation, known as Phantom. So, if you're interested in a pen test or need some security engineering services, we'd love to come help you. We're a relatively, specialized shop, so we try to provide high value, right? And then we've been working on a series of managed products to kind of help our clients more as we start to automate our processes and make some of these products available publicly. So, specifically, some of you probably heard me talk about in the past our Voodoo platform, which is kind of our toolkit for performing red teaming operations. It's cross-platform, so supports Linux, Mac, and Windows. And you can chain those agents together to go as deep as you want into a network. Namely, you can go 15 hops deep into a network if you want to get crazy. And it will relay comms as deep as you want to go. In addition, in this year, we've launched Smite, which is basically our XDR service, which we can also kind of deliver in a SOC as a service type platform. On the offensive side, we also have a Mage service, which is more of a cloud attack surface monitoring platform or management platform. And, we have some additional services we'll be investing in more over the coming years. So I just wanted to give a special thanks at this point in the presentation to Michael Butler. A lot of these cloud techniques we went back and forth and kind of talked about and developed as we did engagements. And he is our pen testing lead over those services. Also, I consulted with Scott Pack, who's Senior Cloud Security Architect at Adobe. awesome guy. He was very helpful in explaining the way some of these APIs work a lot better to me. And then consulted with Wayland Grange on some of the OSINT as well as the Voodoo capabilities for this presentation. He's kind of the creator of that Voodoo platform, and he's done a lot of research in the past, been part of kind of that cyber threat intelligence community. So thank you guys. I appreciate your help. Okay, now for a little bit of an overview on the presentation. So what we're going to be doing first is going to be talking about serverless technologies, cloud provider services, and the frameworks that are going to enable us to kind of do some of these red teaming type operations. So namely, we're going to be talking a lot about AWS's API gateway, AWS's Lambda service, AWS's CloudFormation service, those type of things, right? In addition, we're going to be talking about some of the frameworks or other technologies that are really going to enable us to leverage these services to their full potential. So we're going to talk briefly about Zappa, and then we're going to jump into and talk more about the AWS serverless application model, which is also known as SAM. And there's a few other options out there, but those are kind of the ones we're going to focus on for this presentation. So hopefully, you can stay focused a little bit. And then we're going to take those technologies and we're going to apply them to 3 use cases. So we're going to apply them to the use case of where we want to discover AWS Account IDs. And if you don't know what that is, we'll be explaining that in a minute. We'll also be talking about how we can leverage these technologies to do command and control, or C2, through these AWS services, and why we would want to do that. And then we'll also be talking about how we can leverage these technologies to disrupt AWS's logging services so that an attacker could stay in an AWS account longer without being detected. So, great. Let's jump into it. Okay, AWS services that are going to be relevant to today's presentation include API Gateway. And this is just basically a proxy that's going to sit in front of another service, right? But it's going to be a managed service provided by AWS. So this can sit in front of Lambda functions that are serverless. This can sit in front of EC2 servers, that's kind of like your more traditional VMs, and could kind of act as a front door as others call APIs and send data into these services. There's 2 different ways this can really operate. HTTP APIs are really designed for to be really cost efficient and have low latency, because that's a really common use case with API Gateway. REST APIs offer a lot more features, and you can see a full breakdown of the differences of these modes that API Gateway can operate in by checking out this link at the bottom of the slide. On the last slide of this presentation, there'll be a link to where I'm storing the slides, and you can download the slides and go to any of these references to get more information at any time. I try to include references at the bottom of the slides to help both myself and you guys research these topics more. Okay, and so then Lambda, what's really that? Well, this is one of the core serverless services that AWS provides. And Lambda applications can get complex, but oftentimes they're kind of better described as scripts that are used as kind of duct tape to process data between other AWS services. So, for example, a really simple workflow right here. A photograph is taken, it is put into an S3 bucket for storage, where it's stored as an object, and then when that occurs, a Lambda function is triggered, and then that Lambda function or script runs and does something meaningful with the image, like resizes it to make a thumbnail version, and maybe stores that back in the S3 bucket, so that way an application can access both the original image as well as the thumbnail version of the image that has been created through this workflow. And in this manner, Lambda functions can kick off in response to other actions that other services are taking inside of AWS. There seems to be really good integrations here with the services that you most want to automate and have workflows going through. Frequently this is chained together with objects in S3 buckets, as well as data coming in through API gateways. as well as things like data being stored in databases. And you can even chain Lambda functions together by using step functions, which basically allows you to define, if a certain condition occurs at the end of your function, call this other function, and if another condition happens, call a different function. And so that way you can almost build these complex logic trees that will pass data between functions, albeit there are some limitations there when you actually get into developing the applications that may frustrate developers at first, but feels like every year AWS continues to invest more and more resources into making this into a full-featured platform. So, over the next decade, I expect that this will be able to do everything that you'll be able to do in a traditional web programming language, but entirely serverless. But yeah, today there are a few limitations. But great for really discretely defined tasks, right? You can program in whatever languages are most comfortable you. For the most part, a lot of developers are developing Lambdas in Node using JavaScript or in a Python 2 or Python 3 type environment. There's also some support for like Go, Ruby, Java, and other languages. Really slick integrations with the AWS supported SDKs, especially Bato 3 we'll be seeing throughout this presentation. Super easy to configure permissions around your Lambda function, at least in my opinion. By default, if you just next it, each Lambda function is going to have a new role created associated with it. And then you can go in and modify the policies associated with that role to kind of tailor what exactly this code that's going to execute has access to. Some of those limitations really are scripts have a max runtime of 15 minutes. These are not things that are designed to be long, persistent running operations. So that can get a little bit tricky at times, depending on what you're trying to accomplish. But for the most part, if there's a discrete input, you're processing it, and discrete output, there's a very good option for automating. And one common workflow that we will see throughout today is that similar to this, where a user or another application is going to send data to an API gateway. Then the API gateway is going to pass that data along to a Lambda function, and that Lambda function is going to process the data and may also interact with other AWS services. Like if it needs storage, it might store some data in a DynamoDB database. That's very common for Lambda functions. Or it might need a more persistent long-term storage, and it might store the data back to an S3 bucket, like I was just talking about with the image processing example from before. Both very common, and really sky's the limit. That Lambda function that you're writing can interact with any AWS service that is given permission to talk with. So another service that we'll be using and is CloudFormation. So basically, CloudFormation is a service that enables us to set up other AWS services in a predefined configuration. It really enables an infrastructure as code type methodology. You can have a single YAML file and pass that to the CloudFormation service, and it will attempt to deploy all the others and configure all the other services as defined in that YAML file, right? So you can, really get a really well-defined infrastructure as a service type process going if you are strictly enforcing and making people use the CloudFormation service. There is some notable, issues, which is, one, this is another service in AWS, and the way AWS generally operates is each service is kind of its own team, usually like a small team of, like 8 people. And then so sometimes teams will release features for the service, and then the CloudFormation team is a little bit behind and has not updated their service to enable you to automate the setup and deployment of that new feature on the other service. So there's a little bit of lag time there, but generally they do try to implement all the common tasks that you need to do. So not perfect, but close to it. And I like CloudFormation, especially if you just want to configure things for AWS. Gives you a lot more granularity. Other options like a Terraform type option would allow you to build a template that theoretically could be used across multiple cloud providers like AWS, Azure, and GCP. But the reality behind that is frequently you end up using services or features in each platform, like AWS, Azure, and GCP, that aren't in the other platforms. And so then you basically end up forking your Terraform scripts to kind of be tailored for each cloud platform anyways. So, there's still some more synergies there with a Terraform approach, but the net result is often the same. You end up with 3 different templates that you have to maintain. So, and I feel like when you go directly to the cloud providers, like to CloudFormation, or on Azure, you go to ARMS templates, you gain a lot more power. There's a lot more ability to configure those services exactly the way you specify. So, anyways, that's just kind of a personal preference of mine, but, obviously, use the right tool for the job. A lot of engineers will, have a hammer and then they'll think everything's a nail. That's definitely not the right approach, especially with cloud providers. There's definitely pros and cons with each of these technologies that, you should carefully weigh before, getting kind of locked in on a technology base. So at a high level, cloud providers, they all kind of operate the same way. They basically have these 3 different layers. They have a management UI. This is typically what you see when you first sign up for an account. It's basically the web interface or web console that a user is going to browse around in. And generally the cloud providers, the big ones like AWS, Azure, GCP, they do a good job of exposing the features inside of these web consoles that they want you to be using and want you to know about, or are the most common ones. But really under the hood, as you're clicking buttons inside that website, it's just talking to these control plane APIs. Most of the time it's talking to documented control plane APIs, albeit there are some notable exceptions on all the major cloud providers, where they also do sometimes talk to undocumented APIs. So, if you install, like, for example, the AWS CLI, you can talk directly to the control plane APIs using the CLI and, bypass that whole web interface altogether, generally speaking. And then as you, deploy instances or create API gateways or Lambda functions, that's really creating resources inside your data plane and, enabling users to get to, the great applications or great services that you're building for them. So it's all well and good that you can click around the web interface or you can use the CLI, but at some point, when you have defined what you want your infrastructure or your data plane to look like, you're going to want to automate that. And as we discussed, there's a lot of options here. Each of the cloud providers kind of has their own built-in option that they're pushing for, as well as there's a lot of third parties that just leverage the APIs and they do a fabulous job. Like Terraform is very common, Salt Cloud is great as well, and a lot of teams, they'll just kind of build their own custom scripts, maybe using the supported SDKs like Bato and things like that. So no matter how you're achieving automation, generally anytime you're repeating tasks, that's the route that SREs are going to push towards. And as the automation kicks off, that's going to automatically deploy those resources in hopefully a repeatable and audible way if you're doing infrastructure as code. And as developers, push more features into their code base, they'll push that into a code repository system like a Git server. And then, you'll probably have some CI/CD pipeline. Maybe, you'll have a Jenkins server that will, leverage the APIs or some type of other automation system to seamlessly roll out new revisions of the code as developers continue to push out, new features. So you kind of get this nice workflow going. And frankly, there's a lot of services in AWS and Azure and GCP. It would be really hard for anyone to be an expert on every one of these services. So, at a high level though, they all offer services that are very similar. So my advice is really try not to be overwhelmed when you go into the cloud providers. Pick a use case and then just kind of learn the technologies or services that support that use case and kind of ignore everything else. And then as you do more and more use cases inside of the cloud provider, you can expand and kind of get to know these other services better. Okay, great. Yeah, and once your resources are deployed in that data plane, that's really all the users see. The users don't see your slick automation or how great your CI/CD pipeline is or how smart your SREs are. They just, pretty much hit those resources that have been deployed and interact with the applications you guys have designed. All right, so serverless frameworks. We're going to be talking about a couple today, and trying to make you more acquainted with them. So Zappa is a great serverless framework. Basically, it will take a Python application, like a Flask application or Django application, and what it will do is it will analyze it, and it will build a CloudFormation template to configure and deploy API Gateway and Lambda in a manner that will replicate what is needed to run that Flask or Django application. So this is really sweet for developers who have been on those Python platforms before, because they don't need to know that much about the cloud providers. They continue to just develop those applications on their laptops, and then they can use this Zappa to push out releases to their AWS account. And it kind of obfuscates or maybe hides the CloudFormation piece, which building CloudFormation templates is not, it's not overly complex, but it is something that you have to learn. Where if you use the Zappa framework, you really don't have to learn that technology. You can kind of bypass a few layers and get skip to the end result. So this is great for red teamers. If you write a command and control tool and the listening post side that the red teamer would operate on is written in Django or Flask, with very little effort, you can push that out and make it entirely serverless, running inside an AWS account. So very cool. Hope you guys all go and check it out. Okay, a more comprehensive solution though, that would support additional configurations for developing serverless applications is AWS's Serverless Application Model, also known as SAM. And we will walk through an example of this today. So but this is a pretty comprehensive solution that builds on top of CloudFormation and enables you to build a serverless application in much less lines of code than it would take if you're trying to build a serverless application using a pure CloudFormation implementation. Okay, and really tries to push for that infrastructure as code model based on CloudFormation, but much simpler. And the application example that we're going to be looking at today will be similar to this, where we're going to be deploying an API gateway. And when we hit that API gateway via using like a command line tool like curl, we are going to trigger a Lambda function, and that Lambda function is going to take certain actions, and then it's going to store data. Typically you might store that in a DynamoDB, but just to keep things super simple in this example, I just have the results being stored inside an S3 bucket, which is also a common use case. So, yeah. One thing that I do want to be clear about is SAM is not an AWS service. So it's like a framework kind of like Terraform that builds these CloudFormation templates and helps deploy the resources. And so it's more similar to like a Zappa or a Terraform. It's not like a service in AWS that has its own set of APIs or anything like that. SAM has its own CLI that you download and you can use as you're building and deploying these SAML applications or serverless applications. And the three big things it does that really reduce the amount of code you have to write in your templates is they basically have these new resource types, one for Lambda, one for API Gateway, and one for DynamoDB, that just make interacting with those services a lot easier at the templating level. Okay, so let's just kind of walk through some use cases. I think it's nice to learn about services and technologies, but probably doesn't make a lot of sense until we start actually seeing them be applied, right? So use case number one, we're going to talk about discovering AWS Account IDs, and what you could do after you discover AWS Account IDs, and how we could discover them by writing a serverless application using a framework like SAM. Okay, so what's an AWS Account ID? So when you sign up for an AWS account, AWS automatically generates a 12-digit number. And if you go under your billing section, you'll see that under Account Settings, Account ID. Or if you just look at the drop-down, at least in the version of the web interface, right now it shows you the number, albeit AWS is constantly changing and updating their web interface. So if you're watching this talk a year from now, it may not be there anymore. That's just kind of the nature of AWS. The APIs generally stay the same, but the web interface, when you log in, is always being updated. Now, AWS tries to keep the IDs private, right? Like their own recommendation to their own employees when they give presentations is do not disclose these IDs. So that you'll see in the documentation, they're often redacted. You'll see at the reInvent conferences that they're actively trying to, if employees are following policy, they're trying not to show this data. So you could say it's sensitive, right? But there's kind of two sides to the coin. I kind of deem this as semi-sensitive. Historically, it's really been considered the equivalent to kind of like a username disclosure, in my opinion. But recently there's been a lot more services that have been using this kind of as a additional layer or control before interacting with the service, and we'll kind of talk about that in a minute. So as more services use this as an additional security layer, the impact of it being disclosed obviously goes up, right? So, maybe slightly higher than a username disclosure, which generally is not a big deal, right? All right, so if you have an account ID, it's a 12-digit number. That means, there's 10 possible digits, 0 through 9, and it's 12 digits long. So that's 10 to the 12th, which means there's 1 trillion possible account IDs, right? I'm not a math expert at all, but that seems like a lot. I'm sure it's intentional, but yeah, it just seems like a lot, right? Many vendors, they share their account IDs. Like if you want to do cross-account sharing of services, like specifically to send maybe like logs from one AWS account to another AWS account, you're going to have to share some data with somebody, and generally that means you're going to end up sharing your account IDs. So Duo Labs has a list of vendor accounts under this project here, the GitHub link that you guys can check out. These are all vendors that actively provide their AWS account IDs so that their services will work as expected. You can see a list of these vendors here on the right. These aren't like small companies. These are some of the industry's largest companies. And they're disclosing this information primarily to get certain features to work in their platforms. So you kind of get the vendors or the tech industry saying, should account IDs be protected? No, so that's kind of interesting in and of itself. So what could you do if you knew someone's account ID? right? What's the big deal here? Well, you can interact with some AWS services, and based on their error messages, you can tell whether, certain resources are there or certain things are configured. So for example, roles, right? Generally speaking, when you want to provide access to a resource, you will create a role, and then you'll attach policies to that role, and then you'll attach that role to resources, right? So if you know the account ID number, you can guess role names, and based on the errors that come back, you can see whether those roles exist in the other person's account or not. And then, you can use this data to figure out what AWS services are being used, because certain AWS services, the first time you use them, are gonna create roles that have kind of predictable names. Also third-party vendors, they have predictable role names. So if you know an account ID and you want to see if a particular defensive technology is in use with that account ID, you could guess the role names associated with some of those defensive technologies and kind of recon that out before you even start attacking the account. You can, see if third-party integrations are being used, like Okta integrations and things like that. Really the only defense is vendors would have to kind of more randomize their role names when they're deploying, so that it wouldn't be as easy to guess. Albeit you need to know the user's account ID first before you can even attempt to do kind of a role name disclosure type attack. So once you know a role exists in an account, you could try to assume into that role, and so if there's a policy attached to that role, and if that policy attached to the role is either 1, overly permissive, or 2, misconfigured, there's a remote chance you may be able to assume into that role. And if you can assume into that role, you can do anything that role has permissions to do, and the permissions for that role are really dependent on what policies are attached to it and what those specify. But that could be a foothold or one way to get initial access into kind of an AWS account. You can kind of do the same thing for IAM usernames. You can kind of enumerate based off the error messages whether those are available in the account. Most of the research relating to this comes from, Rhino Security Labs has these 2 blogs that kind of describe that, as well as I just wanted to mention that Daniel did have a script to kind of enumerate some of this data in his repo from I think 2016. So this is not new. This is stuff that's been around for years, and doesn't look like it's going to be changing anytime soon. Other areas that are kind of interesting that I've thought about, and I think others have also thought about, is a lot of people use SNS or SQS services with topics and queues, and they oftentimes have predictable names, and they could be misconfigured so that you could subscribe to those and potentially get messages that you're not supposed to get. But you would need to know the account ID, right? And then you would also need to guess the name of that queue or the name of that topic. So this is pretty similar to what we were just talking about, albeit I haven't seen anybody do it, but I definitely know this is possible based on, what I've seen in AWS accounts. Okay, and then, how would you even get an account ID right now, right? So the known ways to get account IDs is really, I don't know, the easiest way for me personally is I just compromise some type of resource, like in Lambda function or an EC2 instance or something like that. But that's because, I've got years of experience with knowing how to hack stuff, right? And, generally speaking, once you're inside a Lambda function or inside on an EC2 instance, it's not trying to stop you from knowing what account ID it's running under. So that's pretty trivial. But, other ways are, that's hard for most people to do, right? So other ways are a few services that allow you to share data publicly will disclose your account ID when they do so. Like if you share a snapshot or an AMI, any of that stuff publicly. You're also going to be disclosing your account ID when you do that. Another way is, source code review. You might check something into GitHub and maybe it doesn't have credentials, but maybe it's got the account ID for your AWS account hard-coded into it. So, it's kind of unclear. Feels like AWS tries to protect their account IDs, but they're not like straight up saying others shouldn't disclose it. So, you may be able to get this from error messages from services or applications. You may be able to look through screenshots or documentation that the company provides, especially if they have screenshots inside their documentation on how to integrate with their cloud services. And also you can just check out forums or discussion boards. And I think a lot of these were detailed in the Rhino blog posts, so go back and check those out. But these are just pretty common pen testing OSINT techniques. Nothing, no rocket science here in my opinion. But Daniel, he did disclose this in I think 2016, right? Which is really when you sign up for an AWS account, your account ID is going to be by default in the sign-in URL. And the sign-in URL is going to react differently. It's going to give you a 404 if that account ID is invalid, or it's going to give you a 302 if that account ID is valid. So, there's a quick way to check for account IDs to see if they're valid or not. One thing to note here is your sign-in URL can be changed. That's just a configuration in your settings. And it frequently is changed because who wants to remember a 12-digit number? No one, right? So a lot of companies will go in and change these to, be a name or, something that's much more memorable. So it's easier to sign into their AWS accounts more quickly. And we'll loop around to this in a second too. Another thing he talked about was virus total. Basically, looking at that to find valid account IDs. As it indexes data about DNS, this is clearly in the domain, so it's going to also index account IDs as it's doing this. And Virus Total has subsequently updated their API to a new version 2, which has a slightly different syntax. So I wrote a script that is at this URL at the bottom here that will query Virus Total version 2 API and return you back the results, and kind of store those off in a couple different formats to make it easier for you to process. Anyways, if you're interested, it's down there on the Stage 2 Sec GitHub account under the Capture the Cloud repo, which is kind of where I throw scripts for this presentation and some of the previous presentations I did in the past. But anything that really does OSINT or captures data about DNS is going to be really useful to you, right? So, all the way from we've used Passive Total for pen testing engagements in the past, and we tried this with Passive Total, and we got a lot more results than we did from Virus Total. It looks like Virus Total kind of caps us on the results at about 100, where Passive Total we can get a lot more back. So, we get in the magnitude of thousands back, right? So, you can also just try standard pen testing OSINT tools like AMAS that'll query multiple sources. I'm sure Google Dorking and other stuff like that would provide you account IDs as well. And then the one thing I just want to mention here that isn't in the slides, but is important to note is there's a lot of other AWS services, and I should have probably made a list, but that when you configure them and deploy them, by default, they will add in your account ID in some part of the URL for that service. So instead of just mining purely for this sign-in page, there's other URLs that you can mine for, at least a couple that I know off the top of my head, that would also by default disclose account IDs, so you can maybe collect a lot more account IDs that way as well. Okay, but how would we really build a serverless application that would mine and find valid account IDs for us, right? Without any prior knowledge. So we're going to use the SAM to do this. That little squirrel guy is the logo for SAM, and SAM's going to produce a CloudFormation. It's going to we're going to pass it two main things, which is a template that's going to kind of define how we want our serverless application deployed. And then we're also going to pass it a Python application, that's an app.py, and that's what's going to get deployed inside our Lambda function and really have a lot of our logic for this application. So, and when we execute SAM, it's going to build a CloudFormation template, it's going to deploy that, and that's basically going to leverage and work. This is a pretty simple scenario, right? It's going to just stand up like an API gateway so we can, curl an API and trigger this chain. And then it's going to pass data from the curl to the Lambda function. And then the Lambda function is going to try and discover valid AWS account IDs. And then based on whatever results it has in the 15 minutes or less time window it has to execute, it's going to store those results inside of an S3 bucket. So SAM has recently provided very strong integrations and supports for common IDEs. So specifically, they have a strong integration with PyCharm. So while you can do all this using the SAM CLI, the way that I like to develop at least Python applications is by using the SAM extensions for PyCharm. And PyCharm's free. There's like a community edition you just go to and download. And it has some pretty slick integrations that would allow you to test your Lambda code locally, as well as automate pushing out new code bases and reconfiguring and deploying these services as needed. So here's an example template for SAM. And, when you build a SAM project, it deploys a sample template. And there's more in Amazon's GitHub if you're interested, so you can check those out for other options. But, basically this is going to create an API gateway. That gateway is basically going to have one endpoint called /hello that accepts a GET request. And then it's going to take whatever's passed to that GET request and pass it to a Lambda function. The execution or runtime environment for that Lambda function is going to be Python 3.7. One thing that I did here in this example is I attached a policy to this so that we could write out files to the S3 bucket. In this example, I just attached the Amazon S3 full access policy. In real life, you wouldn't want to do that because, that would give you access to all the S3 buckets inside of this account. You'd want to create kind of a more granular policy and then just attach that. But for simplicity's sake, this will work, and it's just kind of running inside a test AWS account anyways. So, and then also you want to modify the max timeout. By default, it's like set to 3 seconds or something ridiculously low. So I just moved that to the max, which is 15 minutes. Which theoretically might cost you more money, but, for what we're trying to do, I calculate that, this thing's going to run between, around 5 minutes a pop. So I just want to make sure there's plenty of time there, a buffer, and for what we need. Okay, and then for application source code, we're just going to keep it really simple. We're going to generate an ID, right? We're going to generate a 12-digit number, and we're going to use the secrets library to do that. So that should be truly random, not like, fake random, right? And then we're going to just try to use the request library in Python to, hit the web console with that in the subdomain list. And then we're going to analyze the results, right? If we see a 302, then we'll know that account ID exists, and we'll write the account ID out to an S3 a file or an object in an S3 bucket. And if we see a 404, we'll know the account does not exist. And I think the script also writes that data out as well, but you could just guard it because we're not really interested in invalid accounts, right? Okay, and then if you have PyCharm configured, which is actually surprisingly easy to do, you can follow this blog post at the bottom here that walks you through how to, add SAM to PyCharm. You just right-click on your project in PyCharm and you say deploy serverless application. It gives you like a pop-up. You have to have an S3 bucket where you're going to store the CloudFormation template and other data that it needs as part of the deployment process. But that's as easy as just specifying a random name because S3 buckets names have to be globally unique across all AWS accounts. And then once it finishes the deployment process, you click on the CloudFormation tab in PyCharm and you'll see either deployment complete or update complete. Update complete if you've already deployed it, things like that. And then if you click over to the Outputs tab, you will see the URL that it created by default to that API gateway created by default that will trigger and pass this data off to the Lambda function. So that's the URL we're going to want to curl to kind of start the code execution process here. So just to kind of highlight what we're going to be doing. So we're going to use curl to call the API gateway URL. When that happens, it's going to call this Lambda function that's going to reach out with the Python request library to the web console to see if the random number it generated is valid or not. And then if it's valid, it's going to store it in the S3 bucket, and then we can analyze the results in the S3 bucket to get a complete list of all the valid account IDs the system was able to find. We're going to deploy this using SAM. SAM's going to create a CloudFormation template and use the CloudFormation service to really deploy out this. And if we want this to continually run, we could just throw our curl command in a cron job, and that will make sure that this process just keeps running perpetually. So in this pretty contrived example, I just set the cron job to run every 3 minutes, and then I put a random delay in the Lambda function between 0 and 3 seconds between each request to the console with a max runtime of 15 minutes. And then I just kind of picked some arbitrary numbers that I thought would work inside this 15-minute window. So I just said every time the Lambda function gets executed, it's going to try 33 times. So it's going to generate 33 account ID numbers. It's going to have a random delay between 0 and 3 seconds. And then it's going to try and hit the portal with those and analyze the results and jam those into an S3 bucket before the Lambda function dies off. And then, if it gets stuck for any reason, which I put the max timeout of the request library at 5 seconds, so theoretically it shouldn't, but if it does, this whole thing's going to kill over in 15 minutes anyways. So when I tested this, for every hour I let this run, I collected approximately 40 valid account IDs. So I got about 302 on 40 different randomly generated accounts. I feel like you could tweak this setup to be a lot more aggressive than I did. I was really just trying to see if this was possible, and looks like as of today at least it is possible. So there you go. All right, and so you can kind of see in my bucket the 302 files that got created, and then kind of a sampling. I just opened up 3 of those files, and it shows some account IDs it was able to get 302s on that it thinks exists, right? Or it should exist based off the response codes we're getting back from these requests. So so that's kind of a simple example of how to build a serverless application using SAM that would allow you to discover AWS account IDs that are valid. A better way to design this, but I just wanted to keep it as simple as possible for the purposes of the presentation, is really to use CloudWatch rather than a cron job with curl. So you can actually, like we talked about before, you can have other AWS services kick off and kind of use Lambda as the glue between them. So you would use CloudWatch as kind of like a timer type service or scheduler type service. So you can use that to trigger an event that would kick off the Lambda function, and then you wouldn't need that cron job and curl command. I oftentimes find when I'm building scripts for red team engagements that I'm not really doing a cron thing like this. I'm more just wanting the Lambda to do some processing. So that's why I typically do that kind of API gateway curl type of implementation. But for this project, this probably would have been a slightly better implementation overall. Well, it'd be a more cloud native implementation. So let's say you have an account ID, but you're unsure, if a resource is actually associated with that account ID. One interesting thing to note is recently AWS has been using account IDs as kind of an optional extra layer of security. And I'll kind of explain why they did this, and then what this means from an attacker's perspective, right? So a long-standing issue in cloud providers is that of a takeover attack, right? Where let's say you have an S3 bucket, and that S3 bucket has a globally unique name. So this name is unique across all AWS accounts across the world. So let's say it's like Bryce rocks, But then one day I just decide Bryce doesn't rock anymore, so I'm gonna delete this S3 bucket. But then somebody else on our team has written a script or has created a website, and that script or website is reaching out to the Bryce rocks S3 bucket for resources due to the objects that were previously stored in there. So maybe, for example, there was like a JavaScript file stored in there previously, and the website would reach out, grab that JavaScript file, and load it as expected. Well, if I decide Bryce no longer rocks and I delete the Bryce rocks S3 bucket, somebody else could come along, and in their AWS account, they could register the Bryce rocks S3 bucket. And then our website would pull JavaScript from somebody else's S3 bucket and load it in the context of the website. And, that could be a really bad scenario, right? So in order to prevent these type of resource takeover attacks, AWS has implemented recently this expected bucket owner option, right? And what expected bucket owner option does is it, you can specify as a client an account ID number, and if the resource or the S3 bucket is has the right name but doesn't have the right account ID number, then the lookup's going to fail. The 403 is going to fail. And so this basically lets you have this extra check that you're pulling a resource or static content from a trusted AWS account, right? So that's all well and good. I think this is actually a great feature. Takeover attacks are really common, and a lot of the bug bounty hunters were really big on them for a while because they're super easy to find and all that. And there really wasn't any defense. Like, clients really had no way to, if someone deleted a bucket and then somebody else registered, there's no way for someone who wrote an application that depended on that bucket to really know that. So I think that's great. But as a consequence or unintended side effect of that, if we have an AWS account ID, but we're unsure if that account ID is associated with the account that's running this S3 bucket, we can now, let's say there's a publicly available resource, like an image in an S3 bucket. We could request that resource. We could see, okay, we can get to that resource. And then we can request that resource again with the account ID that we think might be hosting that resource. And if it comes back successful, we'll know, okay, that is the account ID that S3 bucket is associated with. And if we get back a 403, then we're like, okay, that's not the account ID. Let's try the next account ID. And in that manner, we can kind of use this layer of reconnaissance to figure out, which accounts are hosting what resources, at least when it comes to S3, right? Which is a very common service used on AWS. So I'm not saying this is an end of the world or doomsday type scenario or anything like that. All I'm saying is, you implement one security feature to try and improve things, and the unintended side effect of that is really, if someone is trying to scope out someone's AWS environment and they're trying to map out what resources are inside which accounts, so then they know which accounts they need to be targeting more. This is one way they could kind of do that recon that previously was not available. I mean, this is a very new feature in the AWS platform. Okay, so use case number 2, and I realize this is not new, right? I mean, if there is a way, if there's a service and it has inputs and outputs, somebody's gonna figure out a way to do command and control through it, right? It's not it. I just wanted to show how we could kind of elegantly use these services and why you might want to consider that as a way to augment your existing red team operations. So just to kind of reiterate, tons of blog posts about using cloud providers for domain fronting. I'm not going to go into depth in domain fronting here, but there's a great blog post on this slide that you can go check out in more depth if you want to see how to do that on Azure. In addition, on Azure, we saw 40 North Security. They released a blog post talking about how to build an Azure function. And an Azure function is basically the equivalent of the API gateway and Lambda function combined. So it's their serverless competitor on the Azure platform. And frankly, functions is pretty great. I like functions, but they have a much tighter integration between the mechanism that kicks off the function and the functions code, which has some pros and cons, right? But anyways, here's a blog write-up on how you can redirect comms through an Azure function. It's pretty straightforward. And then, notably, XPNSec, he released a blog post, and this uses the serverless framework. Now, the serverless framework is another framework. You could consider it to be like a competitor to SAM or to Zappa or to, Terraform or something like that. That makes it easy to template serverless applications and deploy them to cloud providers. So he released a template specific for deploying an API gateway with a Lambda function that would redirect comms from a victim, back to a listening post or the red team server. So check that out if you're interested. The serverless framework seems really popular among pen testers and red teamers. But it's like a Terraform, right? It's like a third party that built it and is leveraging the APIs of the providers to deploy it. So, you get some pros with that approach and also some cons, right? So at stage 2, we developed our own cross-platform post-exploitation toolkit. I mean, this is really designed just for red teaming with the intention of never getting caught, right? So, and we, make quite a bit of updates on this every year. As we run into operational issues for ourselves, we'll roll more features in, or as existing clients on the platform request features, we'll kind of add those to the roadmap and roll those out. So, it's got a really intuitive web interface that's multi-user. Anybody who types a command, everybody else can see both the command they wrote and the results from it. Really designed to be OPSEC friendly from the ground up. We try to make this as memory only as possible. We try to get off disk as quick as possible. There's support for pivoting, and I mean deep pivoting, right? I mean, you can go 14, 15 agents deep into networks, and this guy will continue to run like a rock star. one of our major drivers building this tool to begin with was a lot of the open source tools that are out there are great for short-term engagements, maybe 2 weeks or less, but they really lacked the longevity, right? Like a lot of them would stop functioning properly altogether. When you're talking about operations spanning over years, right? And when you get access to a server and you just kind of need some backup beachheads in the network, and it's a long-term red teaming engagement where you're not on a 2-week schedule. You're more like, I'm working for this organization and I need to be able to continually test their systems from a red team perspective. You can kind of leave this guy behind and know that he's always going to be there for you when you need him most. And then it's got other cool features like in-memory only Python interpreter and C# and PowerShell. So can do binaries in memory only. So we really try hard not to ever touch disk once we get running on the box, right? So that means your pen testers, they can be writing scripts, and even if Python's not installed on the target, that's fine. We just load it up into memory and the scripts can run from there, right? Or same with PowerShell, or same with C# and all that stuff. Anyways, that's kind of our thing. And then cross-platform. Most of the engagements we do are for tech companies, so that means a lot of Mac laptops and a lot of production Linux servers with Windows scattered throughout. Okay, so I'm not going to go in depth in all these slides here, but there's a nice interface with where it maps the systems when you first log into the web console. You can have different permissions on different users inside of the platform, which is kind of nice. So if you have a more junior person, they can just have read-only rights, and then you can kind of have your senior operators that are actually able to execute commands on targets. And there'll be some more changes coming to that in the next year. Just as clients have requested more of a tiering system for operators. A lot of different options when how you build your stagers, which are basically, lightweight way to get, the full-blown implant running on your target. You have both call-out options as well as call-in options. You can do some customization of the comms as far as customizing your URLs, your domain names, your ports. There's TCP comms callback, UDP comms callbacks, HTTPS callbacks. And everything is double encrypted, so we don't ever just straight up trust TLS. Even if you're in an environment where they're breaking TLS, it's still encrypted again with their own cha-cha poly encryption underneath it. So, we have some pretty unique techniques, especially on the Linux and Mac side, for defeating tools like OS Query or other process or NetStat monitoring tools. We're basically able to masquerade as any binary on the system. Just make sure you pick a binary that should call out to the internet, right? It's not helpful if you masquerade the echo binary that should never call out to the internet, right? That doesn't make sense, but you can pretty much pick any binary that would normally call out to the internet, like an APT or a yum or something like that, and it'll load that up, suspend it, replace it with the voodoo code, and then resume the process. All right, so typical engagement, we exploit the web application server, we get a callback across the firewall, then we pick up some additional creds, maybe to the database server, we move on to there, and then from there we kind of scan up the data center. Maybe we'll find a monitoring or master configuration management server. We'll kind of, exploit that. As we go, we can load up Nmap or Python into memory only. Voodoo has no issues with that. And then we can pick up some more keys and maybe get to a file server that has the secrets that was for the engagement that we wanted to collect. And, we can kind of pivot or chain through the network, even though these systems that are in the private subnet should never be talking out to the internet. So you could do the same thing to get into SCADA networks or PCI segments or things like that. If two systems can talk to each other and we can get a foothold on each of them, we can chain them together using Voodoo. Now, where typically on red team engagements you get caught is right here, because typically at the border, when your beachhead calls out to your listening post or the red team server on the internet, that's where the blue team's going to focus on. That's where they're going to have the most monitoring detection. That's where they're going to have their their Zeek box or their Bro or their SourceFire IDS or things like that, right? Saricata. That's where they're going to do certificate inspections, things like that. So you really want to make sure that your server that's on the internet looks as trusted as humanly possible. And that's where these services come into play, right? API gateway, it's an AWS service. A lot of people are using this thing to proxy their web applications. It looks very trustworthy. So, one thing that I just wanted to illustrate is API gateway doesn't need to forward back to a Lambda function. I mean, it can literally just by default forward data back to any server you want. So in this example here, you have curl. You curl for a website, you hit the API gateway, and the API gateway can just be configured to send that to any EC2 instance or a DigitalOcean droplet, anything that's running a web server. So it doesn't even have to go back to an AWS account. So in this example, we could have a Voodoo agent could hit an API gateway as a callback, and that could just get forwarded to maybe like another Voodoo LP that's sitting on a DigitalOcean droplet. There's nothing there to stop that. I mean, that's a feature of the platform, right? So, you can kind of get comms like this rolling. And what's great about this is typically you would have a product like Zeek looking at the comms between the agent and the Voodoo LP, which, then you would have to get a certificate, which maybe you could use like a Let's Encrypt certificate, and you would have to register a domain name, which maybe you could get a good domain name and kind of, seed that so it's considered trusted. But that takes work, right? It's a lot easier just to spin up an API gateway on AWS, and then all the Zeek box is going to see Amazon's TLS certificates, which are clearly trusted. It's also going to see an API gateway domain, which is hosted by Amazon, which is also considered trusted. And it's just, it doesn't have any visibility after that where it goes. So, there's a great, cheap, easy way to establish callbacks. I mean, the only issue you're going to run into in this scenario is if, they have nothing in their environment ever talking to anything at an API gateway, which, might be the case for a smaller environment, but as your servers grow and grow and grow, chances are there's at least one team out there that's also using the API gateway for their services. And, chances are high that the servers are going to talk to that. So you can kind of blend in with that noise, hopefully. Okay, another way is API gateway with Lambda, right? So, this has a couple more steps, but I just wanted to show you the basic process, as red teamers often ask about this. So, you have the Voodoo agent, and you just configure it to call back to the API gateway. So you can use, AWS's certificates and their trusted domains. And then it's going to take that data, and what it does by default is it base64 encodes it and then passes it over to the Lambda function. So if you want your Lambda function to do any processing of it, you just need to base64 decode it there. And then you can use URL lib, which is built in by default into most of the Python runtimes that Lambda uses to forward the data onto your LP. Optionally, you could also use install the request library in the Lambda function, which previously it used to be installed by default, but it's not there anymore. They've kind of stripped down the Python runtime environment a lot more. So if you're having issues getting Python dependencies into a Lambda function, in my opinion, the easiest way to resolve this is via SAM templates. When you use SAM, it will analyze your Python code, and it will actually say like, oh, okay, your Python code is using the request library. I need to make sure I package up the request library and make sure that's available inside the Lambda function. So SAM will actually automate some of that process for you and help you out there. So as of right now, if you deploy a Lambda function, you'll be stuck with URL lib, which is pretty limiting. But obviously you could very easily build a SAM template to deploy this infrastructure, just using a slight modification of the code that we saw in the previous example. So I just wanted to reiterate that if you're having dependency issues with Lambda. Okay, and there is a pretty thorough blog post on this. If you go over to the Stage 2 Security Medium page that Waylon wrote up, that talks all about how to redirect fluted comms through API Gateway, and why you want to do that, and how it helps reduce your detection and all that stuff. So if you're a red teamer and you care a lot about this, definitely check that out. All right, so the last use case is really Lambda log disruption, and there's a lot more that could be done here than what I've done to date, but I think this is going to give you a really good base. And this is really only applicable to an AWS account that's already been completely compromised, right? So the only purpose of this is really to stay in the account longer and to avoid detection, which typically isn't a goal of like a pen test or even a short red team. This would typically be more of a goal of like a nation state or APT group that would be out there. All right, so an overview of the AWS logging service. It's called CloudTrail. That's the service we're going to be talking about today. And primarily what it does is, there's other services that create logs, but CloudTrail will log interactions with the control plane APIs. So anytime you're in the web interface and you click a button, that's going to call a control plane API, and if CloudTrail is enabled, that's going to get logged. Anytime you use an SDK that calls a documented API, that API is going to get logged, or at least should get logged, right? There's some notable edge cases, but when Amazon gets aware of pen testers or red teamers abusing those, they generally try to patch those out or fix that so CloudTrail supports logging it. So if you use the AWS CLI, that just hits the control plane APIs and that gets logged as well. This actually does a pretty good job of logging everything inside your account. So you should always have the CloudTrail service enabled inside of all your AWS accounts. And really talking about that automation and cloud management diagram before, every time anything talks to these control plane APIs, which is generally always required in order to spin up resources in the data plane, which is generally your goal when you're using a cloud provider, that gets logged, right? All right, so what's an attacker to do, right? So let's say we have this environment, and every time we, as an attacker, even though we have full access to this AWS account, every time we talk to an API, CloudTrail is generating a log and is storing it in an S3 bucket, which is a common configuration, albeit the CloudTrail service can send logs to other locations besides S3 buckets. But due to complexities with getting logs to other systems, like for example, getting logs to Splunk or getting logs to Elk or Elasticstack or even other AWS accounts, frequently CloudTrail logs are written to an S3 bucket, at least at the very minimum, at least as an interim step. Now, I'm not saying they have to be, or even they should be. It just is commonly implemented that way because it's reliable and easy to do so. Okay, so we could write a Lambda function, right? Remember, Lambda functions can trigger on more events than just an API gateway or a cron job. They can actually trigger whenever a file is written to an S3 bucket. So imagine we have CloudTrail writing to an S3 bucket in an account, and imagine that account is compromised. Attacker has full access to that account. An attacker could actually write a Lambda function that will trigger whenever a file is written to the S3 bucket storing the logs. And then that Lambda function can open up the log and see if it has the attacker's IP address or maybe some other magic string that the attacker wants. And if it sees that, it could remove his action from the log and then write the log back to the S3 bucket. So the only one tricky part about this is you kind of get in an infinite loop type scenario, right? So if you think about this logically, if a Lambda function executes every time a log is written to an S3 bucket, and then the Lambda function modifies the log and then writes the file to the S3 bucket, then when the Lambda function writes the modified log to the S3 bucket, it's going to trigger the Lambda function again. So if you're not careful, your code could get stuck in kind of an infinite loop where you're just triggering a million Lambda functions for no reason. So you just want to take that into account when you're analyzing the logs. The way that I handle this in this implementation is if I open up a log file that does not have the magic string in it or does not have the attacker's IP in it, then I just quit the Lambda function, hard exit out of the Python application, and that kind of ends the cycle. But what that does mean is that when I modify a log, I trigger the Lambda function twice at a bare minimum before the execution state ends, which you could probably be done cleaner than that, but that works. That's good enough. Okay, so we go through this with a hands-on example in the Cloud Red Teaming course that we teach at Black Hat and to companies across the world. We go in great depth on how to do this and much more. We also go into depth on how we defeat log file validation, which is an optional setting that could be enabled when you enable CloudTrail logs. The solution to this stuff really, guys, is don't store your logs in the same account that they're monitoring, right? You need to kind of set up a cross-account trust and enable CloudTrail to write logs to buckets that are in another trusted AWS account. So, there's a lot of documentation out there provided from Amazon and third parties on how to set that up. So that's not like a crazy setup or anything. It's pretty straightforward. One thing that's pretty interesting that I just wanted to show you guys is I call it the buffering dominoes technique. So let's say you have an attacker on the internet and he's interacting with an AWS account. So he has full access to the AWS account, and the AWS account has CloudTrail enable, so it's logging all his interactions at the API level, and then it's writing those out to an S3 bucket in the account. So, the files getting written to the S3 bucket, those don't happen instantaneously. What happens is CloudTrail has kind of a buffering system where multiple events occur, and when that buffer hits a certain size or when the buffer hits a time limit, it will then write it out to the S3 bucket. That way it's not constantly writing to the S3 bucket, because that'd be kind of intensive, right? And not really the way the S3 is designed to operate. So, an attacker does something suspicious, CloudTrail buffers an event associated with that, and in some point in the future that gets written to an S3 bucket, and then maybe another process like a Lambda function or some other process picks that up and moves it into a Splunk server, and that suspicious event gets fed into Splunk, and the attacker gets detected. So for example, like if he does a delete trail, then that will stop CloudTrail logging, but then the delete trail event will get put in the buffer, and eventually when the time limit or buffer size gets met, that's going to get pushed to an S3 bucket. That'll get pushed to a Splunk or Splunk with enterprise security, and then there'll be some type of detection where you'll get busted by a red team. So that's no good. So as an attacker, how can I delete a trail without getting busted, right? Or turn off logging without getting busted? This is kind of ridiculously dumb, but this did work, and to the best of my knowledge, still works, albeit I imagine now that that expected owner feature is implemented in S3, that hopefully the CloudTrail log team will implement that as part of their logging process to prevent this. But I don't know if they've done that or not to date. So if you delete trail and then you create a trail that's very, very similar to the deleted trail, like for example has the exact same name, but instead of specifying the bucket, you specify an bucket name. Remembering S3 bucket names are globally unique across all different AWS accounts. So you specify a bucket name that's in an attacker-owned account. Then what will happen is the delete trail and the create trail event will end up in the buffer. But when the buffer fills or the time limit gets hit, all those events, they don't get written to the owner's S3 bucket that's Splunk or another system is slurping up. They will read the current configuration, which the current configuration says, write this data out to the attacker on S3 bucket. So the attacker will actually get the delete trail message, and the attacker and the defender will never see that. So if a defender is trying to alert on looking for delete trail events, this is a way to defeat that. And now if you get the events in the S3 bucket, you could attach a Lambda function to whenever something gets written to that S3 bucket. And if you have enough writes, you could use that Lambda function to clean out, delete, and delete trail events that are done by the attacker, and then send those data back to the S3 bucket of the targeted account. So that way, logs continue to flow normally to the targeted account, but they don't contain the suspicious events. So you think that might be like really complex, and kind of developing that Lambda function does take a little bit of time, but just doing what I showed you in the previous slides is not that much. I mean, you just delete the trail using this AWS CLI syntax here. Then you create the trail again, and you want to do that really fast, as you can, right? So it's kind of like back to back. But then you specify a bucket controlled by the attacker, and then you start back up the logging, right, with the last one. So that way, when it reads the configuration, it'll send the delete trail event to you, the attacker-owned bucket. If you want to see like a full demo of this, or there's a full blog write-up, you can check out this Medium post here. So it's I did a whole webinar on this and went into it in much more detail. So check that out, or hit me up if you have questions. Well, in conclusion, I just want to say this: cloud, AWS, Azure, GCP, it's awesome. It's the future, super powerful. I think infrastructure as code is going to become the new norm, namely because it's going to be a great audible way to prove that your infrastructure is secure. But in the meantime, as we're kind of all learning these technologies together and all implementing them together, we're going to continue to make mistakes. So we just need to come together as a community to help each other out. If you have any questions, feel free to hit me up. My email is just bryce@stage2sec.com. There's a lot more information on our blogs and webinars. So feel free to, hit us up if you want any more information. We do teach trainings at Black Hat events and a lot to companies directly. Specifically, we have a 2 and 4 day hands-on cloud red teaming, like hacking training that people seem to love. So if you're interested in that, feel free to go to our website, fill out the form. If you're interested in any of the scripts or applications that I wrote in support of this, talk, feel free to check out our GitHub there. I just throw random scripts and that capture the cloud. So, there's not much there, but there should be the examples from this talk and from the previous talk I did at TourCon last year. And then if you want the deck with the references and the slides, you can go to my speaker deck account. Really appreciate you guys taking time to watch this presentation, and stay safe out there. Thanks.